These are the solutions to AQA's GCSE Mathematics Higher Tier Paper 3, and it's from June 2023, so summer 2023. So it is a calculator paper. The first question says, the line with the equation y equals 2x plus 7 intersects the y-axis at A. Complete the coordinate of A. So this wee number here, this is what's called your y-intercept. So it is 7. So you imagine that line, it crosses at 7. And it's got a gradient of 2, so it looks like this, but it crosses at 0, 7. Write down a fraction equivalent to 1.875. So just write 1.875 over 1,000, and then start cancelling down. So I don't think they would be happy with you leaving it as that. So if you just do that in your calculator, press equals, it gives you 15 over 8. And then if you convert that as well into a mixed number, it's 1 and 7 over 8. Next question says solve 5x plus 11 is equal to 3x plus 19, Bring the x's to one side, bring everything else over to the other side, then tidy up, and you'll have just 8, and 2x is equal to 8, so x is equal to 8 divided by 2, x is equal to 4. So a nice start to the exam. Next page, a map has a scale of 1 to 5,000. How many meters are represented by a length of 4.5 centimeters on the map? So the smaller number generally is going to be the map, and then the bigger number is going to be the real. So to get from the map to the real world, in this case, you just multiply by 5,000. So just take your 4.5 centimeters and multiply by 5,000. So 4.5 times 5,000, do it all in your calculator, is 22,500 centimeters. Convert it into meters by chopping off 2 zeros, so 225 meters. It says a number of hedgehogs in England is expected to reduce by 4% each year, i.e. it goes down to 96% each year. Assume that there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs after 5 years. So it's just going to be, we start with 1 million, and it's going down by 4%, which means it goes down to 96%. So that wee thing here, this is what's called your multiplying factor. So to reduce something by 4%, you multiply by 0.96, and it was 5 years, so to the power of 5, do that in one go. Okay, that is crazy, that's 3 marks for that. So 1 million, so 1 with 6 zeros, and then times 0.96 to the power of 5. Okay, so one of these are questions, and we've got 81537.6976. So we'll go for 81537.3, and we'll go for hedgehogs, and I've rounded clearly the nearest whole number. Right, you've got two cubes, cuboid A and cuboid B. So cuboid B is made up of 2 of cuboid A. And it says the volume of cuboid A is equal to 1 to 2. That's fair enough, yep. But Matthew says the surface area of A is equal to the surface area of B. The surface area of A to the surface area of B must be 1 to 2 because B is made of 2 of A. Is Matthew correct? No, he is not. But I think the easiest way to explain this is just to work this out. So if you imagine, here we have got a front and a back, and then you've got one of these vertical sides, one of these vertical sides, one of these flat sides, one of these flat sides. That's what you've got in total. So remember you've the one at the back as well, front, back, and here now you've got one at the front, another one at the front, one at the back, one at the back, but you've got one at the top, only one at the bottom, and you've got 2 at each side and 2 at each side. So if you just give these, you can see you've got the same, you've definitely got double front and back. You've got double the side ones, that would work, but you haven't got double the top. So that means that it's not gonna work at all. So you're gonna say it's not the same, and I'll say because you do not have the top faces, I'll just say no, because B does not have double the top and bottom faces. Okay, so you can definitely say he is not correct. The cannot tell one, it's just not right, because you can see we've got everything else. You have got all those things. You've got, let's just go through that again. You've got the two front faces on the front and the back face on that. You've double that here, and then the vertical ones, I've got one there and one on the other side. I've got twice the amount here on this one, so it is definitely 1 to 2. But here, I've got one of those on the top. I've only still got one of those on the top, and I'd have one on the bottom and one on the bottom, so they haven't been doubled. So you can see it's definitely not, cannot tell. You definitely know it is not correct. Okay, right, this is complete the table of values. So this is y is equal to x squared plus 2x. So how we do this, on your calculator, you do minus 2 squared plus 2 times minus 2. So that's going to be 4 minus 4, it's going to be 0. I haven't done that on my calculator. This one's going to be 1 squared plus 2 times 1. And that's going to be 1 plus 2. That's just going to be 3. And then we've got to plot these. I'm going to plot these very quickly. You have a pair of coordinates here. So minus 3, 3 is here. Minus 2, you're at 0. Minus 1, you're at minus 1. 0, you're back to 0. And 1, you're back to 3. So I'll zoom in on this, see if I can do this in any way. It's very difficult to draw on this. Not too bad. Okay, not too bad. Maybe not great here at the bottom. You really want a sort of smooth curve at the bottom. But on this particular one, the minus 1, 1 should have been my minus and my very bottom of the curve. Okay, so not great, but I've done my best as I can do on this screen. It says Jing has £2,450. She saves some and gives the rest to her 4 brothers. So she saves 2 parts and she gives to her brothers 5 parts. She gives each of her 4 brothers the same amount. Does each brother receive more than £430? Okay, so 7 parts. I would just say 7 parts is equal to 2,450. Work pounds. Work out what 1 part is equal to just by dividing by 7. 2450 divided by 7 is £350. So let's work out what 5 parts is. So multiply that by 5 and I get 1,750. Okay, and then each brother, then there are 4 of those, 4 brothers that she very kindly gave all her money away to. So just do 1,750 divided by 4. And what I got was 437, and then because it's money, 0.50. So does each brother receive more than £430? Yes, and I'm being very impressed with these questions, the way they give you a number, so then you'll know you've got it, and they're quite often close to them, either above or below, so then you can say yes or no. So that's it. So very good questions. Right, pie chart shows information about people at a fair during 3 days. So you've got Saturday, which was some amount here, which we don't know what this is. We'll just work that out. I think we'll just do that before. Not too sure if I need this or not. 80 plus 25 is, 80 plus 25 is 105. And then take that away from 360. That's 225 degrees. Okay, now it says there are 132 more people on a Friday than a Saturday. Friday than a Thursday, apologies. Work out the number of people on Saturday. Right, so we're going to use this. 132 is equal to, so the difference between Thursday and Friday is not 65 degrees, is 55 degrees. So it's 55 out of 360 times my total. Okay, so that's what 132 would be equal to. So what you can just do is 132 and divide it by 55 over 360. And then that will give you your total. So my total is, let me just do it, 132 divided by, I got 864 people. And then on a Saturday is equal to 255 over 360 times 864. So times 255 divided by 360 is equal to 612. There we go. Use trig to work out the value of x. Lovely. Right. This is my relative to this. 58 degrees, that's my opposite. And this is my adjacent. Let's just write down the old SOHCAHTOA. So I've got my opposite and my adjacent, so I'm using tan. Tan of my angle theta is equal to opposite over adjacent. So in this case, tan of 58 is equal to x over 46. Multiply across then, you'll have 46 times tan of 58 is equal to x. So let's just do that. What is that? 46 times tan of 58. Where is it? Where is this? There we are. 73.6 degrees. I've gone to 1 dp. Next one. Okay, Millie is estimating the value of this horrible looking sum here. Sorry, Millie is estimating the value of this horrible looking sum here. She rounds each decimal number to 1 sig fig. Work out Millie's estimate. So okay, so she's gone. Hers is approximately equal to. So the one stays fixed as it would. The 8.38 just becomes 8, and it's a cubed root of 8 squared, and then times 10. Oh, you nearly could have done that without a calculator. So that's going to be, the cubed root of 8 is 4, and then, cubed root of 8 is 2, and then square it, you get 4, and then times 10. So it's going to be 1 over 40. If you have that written down, and then you just do that as a decimal as well, you're not going to lose any marks. So 0.025. Not too sure which they would be looking for here. There we are. Okay, Millie says my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this, how she does know this. Okay, I have no idea. Let's have a look and see. So my answer, she says my answer must be more than the exact value. Okay, now the reason is she has rounded hers down. Okay, so she's rounded hers down. So hers have both been rounded down. The 8.34 and the 10 have both been rounded down. So if her my estimate must be more than the exact value. So to make a fraction, so she has rounded hers down. So is dividing by a smaller number. So the mathematical word is the quotient. That's the thing that you're dividing. Must be larger. Okay, right. Let me just explain that. If you're doing, say you had a fraction, say A was equal to B over C. To make A maximum, so the maximum A, what you would do is you'd make it maximum B on the top and minimum C. Okay, likewise, if you reverse that, if you want minimum of A, you'd make it as small as the top on the top, and you'd make it maximum on the bottom. Okay, so for us, she has made both of these things as small as possible. So that means the bottom line is as small as possible overall. Then the overall the thing is going to get bigger. Tricky enough wee question to explain. Right, here is a biased spinner. Biased spinner means an unfair spinner. So you've got 1/4 1/4 red then, clearly. Just write this in here before I scoot on down. You've got 1/4 red and you've got 3/4 green. Ali, Ben and Carrie, A, B and C, want to know the probability of spinning red on the bias spinner. They each spin it and count how many times it lands on red and divide by the total. So Ali says, I spun red most times. Ben says, I spun the spinner the most times. And Carrie says, my relative frequency of red is 0.25. Who had the best estimate of spinning red? Okay. Right. Who had the best estimate of spinning red? Tough one. I think it's actually going to be Ben, because he has spun the thing the most times, and that really is it. If you perform, it's called relative frequency. If you perform a task the most times, for example, if you roll a dice 6 times, you maybe only get a 5. You maybe don't get a 5 at all. You maybe get a 5 twice, and so on. But if you roll dice 60 times, it's going to be more accurate. But if you roll it 600 times, the probability of getting a 5 is going to be more accurate. 6,000 times, the probability of getting a 5 is going to be more accurate. If you rolled it 6 million times, roughly 1 million times, then you would expect to get a 5. The more times you perform it, better. Okay. Now, it says it's a bias spinner. We don't really know. It could be clearly a quarter of it is red, and the other 3/4 is green. But you don't know how it is weighted. It may be weighted slightly differently as well, so it might not be the case. So that's why they've put this in. The relative frequency of red is 0.25. Ben, and we'll just say Ben, he is the one who has spun the most. So Ben, we'll just say he has performed the experiment the most times. I would be interested to see what they actually say in the mark scheme for that one. Let me know in the comments if you disagree with me there. Okay, right. Dev spins a spinner 80 times. He says the relevant frequency of red is 0.85. Give a reason why his relative frequency 0.185 must be wrong. Right. Okay, well, his relevant frequency must be wrong, because he has got so many this number of reds, and he's divided by 80, and he's got 0.185. Let's just multiply across. If you do x equals 80 times 0.185, 80 times 0.185, let's see what we get. We get 14.8. So we'll just say he didn't roll, or it's impossible to roll, we'll say, and he didn't. Just say it's impossible to roll 14.8 red. So he's made a mistake in his calculation. Okay. Elena spins a spinner 125 times. Her relevant frequency is this. Work out how many times the spinner landed on green. Okay, so that means if that's her relevant frequency for red, we'll just work out the number of red then is equal to number of red divided by 125 is equal to 0.32. That means the number of red is equal to 0.32 times 125. 0.32 times 125, which is 40. So she's got 40 red. And then number green is equal to 125 minus 40, which is 85. Hopefully that's us done on this question. Haven't enjoyed that question, I must say. Okay, next question. Happy days. Charlie is driving 293 miles home. He leaves at 9 a.m. He travels the first 176 miles at an average speed of this. He travels the rest of the way. So we need to work out how many miles that is, first of all, at an average speed of 65. Will he be home by 2:30 p.m.? So we need to work out our total time. Okay, right. We'll say, first of all, we'll work out the first time. So we have got our distance equals speed times time. There's a triangle. So if you cover up time, you're left with d over s. So my time is equal to distance divided by speed. So 176 divided by 48. 176 divided by 48 is, and I'm going to say that's 3 2/3 of an hour. Okay, so or 3 hours 40 minutes. Right, the second stage then, so the second distance first of all then is going to be equal to, it was 293 was the total distance. Take away 176 then. 293 take away 176 gives me 117. That means the second time is equal to distance divided by speed again. So 117 divided by my speed, this time of 65. 117 divided by 65 is equal to 1.8. Okay, so that's 1.8 hours. Okay, right, let's work this out. 3 2/3 hours is 3 hours 40 minutes. 1.8 hours. Okay, just on your calculator, do 0.8 times 60. 0.8 times 60 gives you 48, so it's 1 hour 48 minutes. So if you add those, now look at this wee trick, add them both really awkwardly, add the hours, that's 4 hours and 88 minutes. Okay, nobody does 4 hours and 88 minutes. So that's 5 hours and 28 minutes is what we've gone. And you started at 9 o'clock. So let's just do 9 a.m. and we're going to add on 5:28. So that's just going to be, add the minutes, you just get 28. Add the hours, you get 14. So 14:28. And will she be home by 2:30? Oh, she's just home, yes. Home just before 2:30 p.m. because remember that is 2:28 p.m. in the AM PM clock, 12-hour clock. Okay. Oh, income tax. Love an income tax question. Right. Kieran paid income tax and national insurance on her annual salary. So income tax, 0% of the first £12,500, £12,570 of her annual salary, 20% of the rest. And then national insurance is 0% on the first £9,980 of her annual salary and 13.25% of the rest of her annual salary. How much income tax did she pay? How much this? Okay, so, right, income tax first of all. To do this, I'm going to use what's called the bar method. Now, a colleague of mine showed me this a few years ago, and this makes life so much easier. Now, this is my income. Kieran's income is, his income tax is, this is a different way of asking it. Oh, very good. Right. This has changed how they've done it. Right, I'm going to come back to this one in a wee second. I'll do the national insurance first. I need to find his salary. I can't. I've got to find his salary first. Okay, right, great. I haven't seen any question like this before. Right, normally what I would do is I would work out what is in the 0% box. So that was the income tax. He's not getting charged for the first 12,000. And then, so he pays 0% on that, as 20% on this. That's how we're going to work it out. 0% of anything is 0. And then his income tax, because there's nothing else, this has to be then, this one here has to be 5,182. Okay, so we can sort of reverse engineer then to find this missing thing. So to get that thing, I would have said, I'll call that X for the time being. I'm not going to really get rid of that in a wee minute. But say I had done 0.2 times X, I would get 5186, which means X is equal to 5186 divided by 0.2. So if we just do that, 5186 divided by 0.2, I will get 25,930. So that's in here, that's £25,000, 930. Okay. Now, put on what the total is of these two things. So just add on the 12,570, which is tax-free, which is 38,500. So we now know what Kieran actually earns in a year. And then we can do the national insurance. So now this is what I thought this question was going to be. I'm going to do this in red. You obviously can't use red. I'm just doing this to distinguish between the two parts of the question. And we're going to use the bar method again. I now know he earns 38,500, so put that at the end of the bar. And for the for the national insurance, the first 9,880, he pays nothing, so 0%. The next bit, he pays 13.25, so it's on the rest. So to get this thing here, I do 38,500, I'll just do the working out here, 38,500 minus 9,880. So minus 9,880, which gives me 28,620. So you just do that and multiply by 0.1325. That was 13%. And that gives me 3792.15. Okay, and that is it. So how much income tax and national insurance did he pay? There we are. So a good bit to do in that question. That's a tough question actually. That's good. Enjoyed that one. Okay, I've never seen that first wee bit before. That hasn't come up. As I've maybe said in the other videos, I normally do CCEA. That's what I teach. But so it's nice to do different questions. Oh, right, histogram. And histogram questions on CCA are not quite often the worst questions. So we'll see what they're like here on AQA. Okay, we've got 180 runners started the marathon. Some of the runners did not complete it. The histogram represents the times of the runners who did complete the marathon. Okay, so it says 180 started it. So it says how many runners did not complete. So we've got to work out all of these the frequencies of each of these bars, basically, so the area of each of these bars, and find the total, and then we can take that away from 180, because these people in the histogram are the ones who did complete it. So to find the frequencies, the frequency is on a histogram is equal to the area of the bar. That's it. So just do the width here, which is 20 times 0.6. And I'm doing this on my calculator. Don't try and be a hero. Just do it all on your calculator. 20 times 0.6, which is just 12. The next one is 20 times 1.6. 20 times 1.6, which is 32. Next one is 40 times 1. Sorry, that's wrong. That is wrong. Apologies. It's not 20 times 1.6 at all. Check your graph. Check your thing here. Each wee box in this represents 0.5. 0.05, I should say. So that's going to be 6, 7, and that's going to be 0.8. So it's 0.8 times 20. 0.8 times 20. which is 16. The next one, that's going to be 1.6, 1.7, that's going to be 1.8. So 1.8 times 20, which is 36. The next one is, that's going to be 1.1, that's 1.2 then. 1.2 times 40, 1.2 times 40 is going to be 48. Next one, that's 40 again, and it's 40 times, and that would be 0.6, 0.7, 40 times 0.7, 0.7 times 40 is 28. And the last one, so from here to here, that's going to be 60 wide, the last one, and it is 0.4, 0.4 times 60 is 24. Okay, so the total, let's add those up. We'll just say did complete then is 16 plus 36 plus 48 plus 28 plus 24. So that's going to be 16 plus 36 plus 48 plus 28 plus 24, which is 152. So they did not complete, did complete. So did not complete then is, I think it said 180. I'll just check that in a wee second. 180 minus 152, which is 28. Let me just check that. Was 180 people did start, so there you go. So you've got to work out the area of the bars. Be careful with the scale. You saw me messing that up there. Just check the scale. And then find the area of the bars, and then take it away. Right, hopefully that's us done. It is not. Okay. Right, the table shows information about runners who did not complete the marathon. Okay, right, so these are the runners who did not complete the marathon. Right, so there we have it. So draw a box plot to represent this information. So box plot needs the least value, the greatest, the lower quartile, median, upper quartile. We're good to go. We're good to draw this, aren't we? Yep. So least value was 5. The greatest value was 23. So again, 2 wee squares represents 1. So that's going to be 21, 22, 23 then. Right, where's my lower quartile was 11. So 11 is going to be here. And I'm going to just do 3 wee a line. Use a ruler. I've done a line 6 high. There's 11. My median was 18. So 18 is going to be 4 wee boxes shy of being 20. And what's the last one? The upper quartile. Where's my... Oh, it doesn't tell me my upper quartile. Sorry, it told me my interquartile range. The interquartile range is 9. So from this, I can work out my upper quartile Q3 is equal to my lower quartile plus my interquartile range. So it's going to be 11 plus 9. So my upper quartile is 20. So there's my upper quartile. It's 20. There you go. Right. You use a ruler. I'm not using a ruler. This thing messes up if I touch the screen with a ruler, so I'm not going to bother. There we go. Box plot done. Right, hopefully that's not done in the old histograms, is it? Happy days it is. Thank goodness. Right. We've got a right angle triangle. Work out the area of the triangle. Right, so you've got this right angle triangle. A is equal to 16. Let's just label that as 16. And A to C is 4 to 5. Lovely. I haven't seen a question done this way in a while. Right, A to C is in a ratio 4 to 5. So we'll just say 4 to 5 is equal to my A, which is 16, to my side C. You can do this lots of ways. I like to use a fraction method. Write that as a fraction and then do a little cross multiplying. So 4C equals 5 times 16. What is 5 times 16? Is it 80? It is indeed. That means C is equal to 20. Okay. And then by Pythagoras, you could work out your B. Okay. You should already know this, by the way, because you should be familiar with this triangle, which is a 3, 4, 5 triangle. And if you multiply the 4 by 4 you get 16, the 5 by 4 you get 20, So the 3 would also get multiplied by 4 to give you 12. But we're going to pretend that we don't know that, and the reason why I'm doing this as well is they could ask you one where it's not what's called a Pythagorean triple. A Pythagorean triple is just three numbers which work nicely in a right angle triangle. For example, 3, 4, 5. Or, oh my goodness, I'm trying to think of a different one. 25, 24, and 7, I think. Let me just check out. 27 squared plus 24 squared equals square root. Yep, that would be another one. So they would work nicely in a Pythagorean, a right angle triangle as well. Okay, there's loads of other ones, and I've just had a complete blank there. So anyway, right. We're going to show you how we work out this C, the side B as well. We need it for the base. So C squared, my hypotenuse, is equal to A squared plus B squared. And I like to always say start with hypotenuse. And then we can just work that out. Don't bother actually working out what's 20 squared and 16 squared are. You're in a calculator exam, so just use a calculator. So square root button, then 20 squared minus 16 squared. And you can see you get that gives you your B, and your B, as I'd expected, was going to be 12. Okay, the area of the triangle then, remember, is area is equal to half times base times height. So for you, the area is equal to half times the base. We've just worked out the base to be 12. The height, they told us, was 16. So that's just going to be, just do that again, half times 12 times 16 works out nicely to be 96 centimeters squared. Lovely. Okay, algebraic fractions, and a nice one. This will lead to a linear equation. Right, if you were adding a half and a fifth, what you would do is take a common denominator, and your common denominator would be 10. Same idea here. So that's all we're doing here. So I'm going to do one big fraction. This 2 got multiplied by 5 to give it 10. So its top line gets multiplied by 5. Use brackets. This 5 got multiplied by 2. So its top line gets multiplied by 2. And then that's just, I think what I'll do, I'll not multiply out, I'll multiply across. Now the order you do this doesn't matter too much, and you're not breaking any mathematical rules, but I'm bringing this 10 across and multiplying, so it's going to be 40. Now I'm just going to multiply out. That'll be 5x plus 40 plus 18 minus 2x is equal to 40. Before you do anything else, tidy up. That's going to be 3x plus 58 is equal to 40. Now bring the 58 across. If you started bringing stuff across at that stage, you're bringing across two things. So that means you've twice as many opportunities to make a mistake when you bring something across. So tidy up first before you bring it across. Just be sort of tidy in your mind as you're doing this and your processes, and makes life so much easier. So 40 minus 58 is minus 18. That means x is equal to minus 18 divided by 3. So x is equal to minus 6. That could be on your non-calculator paper quite easily. Very nice wee question. Right, wee bit of function stuff. And again, this is something that doesn't come up too much at GCSE. It doesn't come up at all, GCSE level at CCEA module. But it's on this, and it's nice stuff. Okay, this is what's called a composite function. So what f g of x means, it means you do your g of x first and then you do f to it. Okay, so let's think about what is f actually doing. F is doing is whatever you put into the f gets squared, and then you do 6 times it. So f g of x then is just going to be, my g goes in, 2x plus 4. It gets squared, and then you do 6 times your g. Now, take your time with this. Do 2x plus 4 times 2x plus 4. I haven't even done anything here with this, I've just written it out again. But if you don't do this bit, people mess up that expansion of double brackets. 2x times 2x is 4x squared. 2x times 4 is 8x. 4 times 2x is 8x. 4 times 4 is 16. And then 6 times 2x is 12x. 6 times that is 24. Tidy up time. And you will get 4x squared plus 28x plus 40 as required. Lovely question, because you know you've got it right. Okay, next thing it says, solve g(f) of x is equal to minus 5. So that means this whole thing must be equal to minus 5. So put minus 5 equal to 4x squared plus 28x plus 40. It's quadratic. Bring everything to one side. That's what you're going to have. Bring it, so it's all equal to 0. And then use your quadratic formula. I think just it might factorize, but it might not, and you could have wasted a long time trying to factorize. So using your quadratic formula, that's what you're going to have. So that was your, sorry, I didn't even say what that was. That was minus b plus or minus the square root of b squared minus 4ac. So here your a was equal to 4, your b was equal to 28, and your c was equal to 45. Use brackets where I've used brackets because especially if your b is negative, if you don't put it in the negative sign in the bracket, the calculator will mess it up. Okay, I'm going to do the negative one first. Fraction button, minus 28 minus square root 28 squared minus 4 times 4 times 45, is that? I can't even read. And then over 8. And I'm guessing this would have factorized because I got minus 4.5. And then x is equal to the other one then, so doing the positive one. I got minus 2.5. And there's no reason why it couldn't work. Nope, looks good. This question is an algebraic proof question. It says two integers have a difference of 6. The integers are multiplied together. 9 is then added. Prove algebraically that the result is always a square number. Okay, I'm going to say let the first be equal to n. And if we have a difference of 6, I can either let the second be equal to n plus 6 or n minus 6. I'm going to go for n plus 6. So the integers are multiplied together. So n times n plus 6, and then 9 is added. And it says prove algebraically that the result is always a square number. So I'm going to look at this expression. I'm going to multiply it out. That's what I get. Oh, and then that factorizes. That could be written as n plus 3 all squared, i.e. that's a square number. Okay, because the definition of a square number is a number that could be written in the form n by n, so something times something else. So this one really is written as n by n plus 3 times n plus 3, so it's always going to be square. Lovely question. Okay, Sunil thinks that E and D are linked by the equation. E is equal to 36 over D. The graph shows the value of D and E for 2 is less than or equal to D is less than or equal to 6. Choose one point in the graph and state if Sunil's equation is correct at that point. Okay, right, let's pick a nice point, if there is a nice point on this, is there? We'll go for this one. We'll go for that point there, which is 3.6. So the point I'm looking at is 3.610. So mark that down, 3.610. What was my thing? 36 over D. I think it's going to work, yeah. So we'll just say E equals 10. And then 36 over D would be 36 over 3.6, which equals 10. So correct for 3.6, 10. All right. Is that it? Right. Right. D is different question. And G is directly proportional to the square root of h. So let's write that in first. So G is directly proportional to the square root of h. It says G to h is 3 to 2. They seem to be very fond of ratios in this question, this exam. G to h is 3 to 2 when h is equal to 16. Work out G to h when h is equal to 100. Okay, right, I have no idea. Let's just get started. I'm just going to put in h equals 16. So G is going to be equal to, that's going to be k times the square root of 16. So G is going to be equal to, that's going to be 4k. Now it tells you also when h is equal to 16, G to h is 3 to 2. So that means if G equals this, that means therefore 4k, G to 16, that's G to the my h is equal to 3 to 2, and this asks, but this allows me to find my k then. Very good. Right, so let's just do that using the fraction method again. 4k over 16 is equal to 3 over 2, and we'll do the old cross multiplying then. So 2 times the 4k gives you 8k, and 3 times 16 gives you 48. K then is equal to 48 over 8, which means k is equal to 6. Once you find a constant in a question like this, you rewrite your equation. So I'm going to rewrite this equation as G is equal to 6 times the square root of h. Then it says work out G to h when h is equal to 100. So find your, just say when h equals 100, G first of all is equal to 6 times the square root of 100. So that's going to be 6 times 10. So G is equal to 60. And then we'll just do our G to h is 60 to 100. And that's just going to be 6 to 10, which is 3 to 5. And I don't think you would simplify that any more than 3 to 5. That would do you. Otherwise you're going in, you could write it as 1 to 5 over 3 or whatever, but it's not going to be too nice. (21) says a solid shape is made from centimeter cubes. The front elevation and side elevation of the shape are shown. So you've got the front elevation and the side elevation. Okay, right, and it says work out the maximum possible number of cubes in the shape and the minimum possible number of cubes in the shape. I have no idea. Right, okay, your front elevation and your side elevation. Okay, right, I think I have to draw a wee diagram of this thing. So, is that my front? I haven't done these in years. It's not something that ever comes up on ours anymore. Okay, maximum possible cubes. Right, I think that would be the maximum that we could have. Okay, for the maximum. Right, so for the maximum, they're made up of 1 centimeter cubes. We just have to work out this volume. This is not easy. Right, okay, we have got the work out this wee area. So this area here, that would be 2. That'll be 2 centimeters. So A is going to be 10 centimeters. And this area then, that would be 7 by 8. So if I call that B is going to be 56 centimeters. So the total is going to be 66. So it's the number of cubes. So we're looking for the volume. And this length then is Yep, that is 9. That is 9 by 12. Sorry, that doesn't matter. That, sorry, we're just so this length here would be 12 then. So we've got that whole area is 66. So 66 times 12. So the maximum is 12 times 66. 12 times 66, which is 792. 792. Okay, right, how can I make this as small as possible? Right, there's my side elevation coming in here, and the minimum it has to be made up is one lot of centimeter cubes, if you know what I mean. But we also need to have this front elevation, so it needs to be like that as well. But the rest of it then could disappear. So I could technically get rid of the rest of it. So I need to just take off those two faces. Or one, sorry, not those two faces, that's because that one's one deep. So I need to take off, if you imagine, that is, if I zoom in on this, that is 1 wee centimetre here, that's 1 centimetre. So I need to have the 66 end, that's 66 single cubes. And then I'll need to take off as well 11 by, I think my height was 9, wasn't it? 11 by 9, yep. So the minimum, I'm doing this in red then, is equal to 792 minus that end, which is 66, minus and a 9 by 11 rectangle, because that means everything else in behind would be getting chopped off. So if I drew the diagram again, that's what it's like. It's sort of like a shell, like a wall nearly of a house with nothing inside it. Okay, so it's just like a wall, it's not a solid object. And if we do that on our calculators, so 792 minus 66 minus, and then 9 times 11, that is 627. If somebody could let me know in the comments if this is a common question that comes up, because that's difficult to get. That is not easy. I have to say I wouldn't like to have to try and explain that to people. Year after year, it's not easy at all. Okay, right. Anyway, shape A and shape B are shown on the grid. Describe a single transformation that maps A to B. Okay. It is some sort of enlargement. Now we need to find the center of enlargement. We'll do that first. So this corner comes from here. So if you link that up, I wish I had a ruler, but if you link that up, that's where they go. And then this corner also comes from here, link those up. That's not been much help to us. And this corner goes to this corner. So if we link those up, with a straight edge, if we had a straight edge, I have a birthday card here, and we use this birthday card, hopefully it doesn't. Okay, I'm going to guess that's where my centre of enlargement is, but I'm going to do one more. So this, the really pointy point, it comes from here, and you can see it goes through the same place. So there's my centre of enlargement, and what was that point? It was 7, 4. Now, it's an enlargement. I need to work out the scale factor. It's going to be negative because the enlargement is on the other side. So it's shape A and shape B are shown on the grid. Describe a single transformation which maps A to B. So it's enlargement scale factor. And 4 squares becomes 2. So it's halved. So it's minus a half. And the center of enlargement we have just worked out as being 7, 4. Okay, so 4 went down to 2, so it's half as big, and it's on the other side of the center of enlargement, so it must be a negative scale factor. Oh, bearings question, everyone's favourite. Bearings question. A boat sails 35 kilometres north from A to B. The boat sails to C and then back to A. Show that the distance a boat sails from C to A is 79 kilometres to the nearest kilometre. Okay, right, let's do a wee bit of working out here. This will be 100 degrees first of all. And what else do we know? We just need to find this thing x. So it's actually, this is, after we've done that, this is just a cost rule question because you've got a side, and the included angle. So that's why it's a cost rule question. Right, I'm just going to write my cost rule down here. A squared equals B squared plus C squared minus 2BC cos A. So in this case, x squared is equal to 35 squared plus 65 squared minus 2 times 35 times 65 times cos of 100. File that into your calculator and square root it, and you'll get your x. Nice as well, because we sort of know if we're right down because of the way they have done it. So because they've told you it should be roughly 79. So let's just do that. 35 squared plus 65 squared minus 2 times 35 times 65 times cos of 100. And square root it. Square root that answer. And I got 78.994299 will go to. So then that is 79 kilometres to the nearest kilometre. Happy days. And you know you've got those full, only 2 marks for that question. Only 2 marks, but you still got the 2 marks. Next one says, work at the bearing of A from C. So A, it said what it told me here was A from C. So from C means I'm starting at C. And people get this wrong all the time. So they do the wrong way around. So that's what we're looking to get. So to get this, by interior angles of parallel lines, I know this wee angle here is 100 degrees. Because this one was 80. 80 plus 100 adds up to 180. So then if I knew this wee angle and call it theta, then I could work out, take 100 and theta away to get my bearing of C. So I'm going to do this here just because I've got the diagram. So this is my part B. I'm going to use my sine rule. So sine of theta over its opposite side, which is 35, is equal to sine of 100 over its opposite side, which is, and notice I'm using 78.994299 because it's more accurate than what my other answer. So I mean sine theta is equal to 35 times sine of 100, and that's all over 78.994299. And then do shift and sine to get your angle theta. Let's just do that. 35 times sine of 100 all over 78.994299. Shift and sine of my answer. And I got 25.87 degrees. Okay. Now remember what my answer I'm looking for. I'm looking for that blue circular angle there. So that is going to be 360 minus 100 and minus your angle theta. So my bearing, where is it? Sorry, going all over the place here. My bearing, 360 minus 100 minus 25.87. Haven't gone to too many decimal places here. Okay, and what I've got is 234 point, and we'll go for 0.1 degrees. That's the 1 dp. Okay, tough enough question. Is that us finished? It is. Enjoyed that one. Very good. Right, some tough questions in that one. Someone's very different than what I would be used to, with this one especially. So again, please, if somebody can let me know in the comments if this is a type of question that comes up quite a lot, I'd be interested to know, just for my own interest. Question 21 are elevations and front and side elevations and so on. This used to come up on our sort of lower tier exams in CCEA, but you would never have had it on the maximum and minimum possible blocks or anything like that. It would just been give you a front elevation, side elevation. You maybe had to draw a 3D shape. That was about it. Okay, thank you very much.